Welcome back. Section 2-1, echelon form of a matrix. Echelon means steps or stairs. So echelon form of a matrix, it's a very important topic. Recall the method of elimination we learned in section 1-1. Suppose we want to solve this system. 2x minus 6y plus 4z is 10. 3x plus 5y minus z is 12. 4x plus y plus z is 7. So these are three equations, 1, 2, 3, in three unknowns, x, y, z. We want to solve this system. What do? If you recall, we wanted to get a 1 over here first. Get a 1 over here. So I'll divide throughout by 2. When I divide the first equation by 2, and notice I'm renaming, okay? So I'm calling the divided row again row 1. Divide the first row by 2, I get x minus 3y plus 2z is 5. So divide throughout by 2. The other two equations are as they are. Now, my goal is to get a 0 here and a 0 here. What do? I multiply first equation by negative 3 and add to the second equation. Multiply the first equation by negative 3, add it to the second equation. So negative 3x plus 3x gets me 0 here. Negative 3 times negative 3, positive 9 plus 5 gets me 14 here. Negative 3 times 2 is negative 6, minus 1 is negative 7. Negative 3 times 5 is negative 15, plus 12 is negative 3. So my second equation has changed. First and third equations have not changed. Now I would like to get a 0 over here. Same story. Multiply the first equation by negative 4, add to the third equation. Let's go back. I need a 0 here. Multiply by negative 4, add it to this one. This is why we get a 1 here, okay? All right. Assuming my calculations are correct, I get a 0 here and 13, negative 7, negative 13 here. So now, that's my first equation. Second and third equations do not have 0 at all, do not have x at all. So second and third equations are in terms of y alone. My goal is to get a 1 here. We probably see a quick way of solving this, right? You can eliminate z, but to keep the algorithm, follow the algorithm as we just saw, divide the second equation by 14, you get a 1, you get a negative half, you get a negative 3 over 14, you obtained a 1 here. Now multiply the second equation by negative 13, add to the third equation to eliminate y. Okay. Second equation, multiply by negative 13, add to the third equation, and that y became a 0. Now all you have in the third equation is z. I can solve for z. Multiply by negative 2 to clear the negative and the 2. Here you go. Z is 143 over 7. Now work backwards. Now that you know what z is, substitute this in the previous equation to find y. Z is 143 over 7, which you plugged into the previous equation to find y. You know z, you know y, you can find x. You see, this is what working backward looks like. Take this z, place it here, find y. Once you have z and y, place those two values here to find x. Okay, it helps to have 1x, 1y, and 1z. Calculation becomes easier. So this is the substitution backward. Since all the calculations were performed on the coefficients alone, notice we didn't change x, y, z, just we changed the coefficients. Let us consider the sequence of steps on the augmented matrix of the system. Augmented matrix, remember, you write all the coefficients and you write all the outcomes on one bigger matrix with a line dividing the coefficients and the outcome, right? This is the augmented matrix. So what do? So keep in mind, you try to get a 1 here, you see, because that was the first equation, first variable. Try and get a 1 here. Divide the first row by 2. Divide the first row by 2. All right. Now I want to get a 0 here and a 0 here. So I use -3 times row 1 added to row 2. -4 times row 1 added to row 3. Row 2, replace row 2 by row 2 plus row 1 times -3. You got a 0 there. And these numbers here. Check again. -3 times 1 plus 3, 0. -3 times -3, 9 plus 5, 14. -3 times 2, -6 minus 1, -7. -3 times 5, -15 plus 12, -3. So that got you a 0 here and some numbers here. Now you're going to take this row, multiply by -4, add it here, okay? Replace row 3 by row 3 plus row 1 times -4. Same story, -4 times 1 plus 4 is 0. -4 times -3 is +12 plus 1 is 13. -4 times 2, -8 plus 1, -7. -4 times 5, -20 plus 7 is -13. All right, so you had a 1 here and zeros below. Now you need a 1 over here. What did we do? Divide row 2 by 14. Go back. Row 2 by 14 to get a 1 over there. So 1 here, -12, -3 over 14. Check again. 1 dividing by 14, -12, divide by 14, -3 over 14. Very good. Now that you have 1 here, get a 0 here. Okay, below. So what is that? Replace row 3 by row 3 plus row 2 times -13. Multiply second row by -13, add it to row 3. -13 plus 13 is a 0. -13 over 2 minus 7. Notice negative times -12 is +13 over 2. +13 over 2 minus 7 is -12. -13 times -3 over 14 is +39 over 14 minus 13. Check my calculation. Make sure you get this. That's fantastic. Now we have the third row where it's 0 here and some fraction here. I want a 1. So I need to multiply row 3 by -2. You get 1 here and -2, that will reduce this. You get 143 over 7, the same numbers. Now we can work backwards, you see. By the way, working backwards, right, working backwards, just as we did previously, gets you Z, then you get Y, then you get X. What the matrix you have right here with 1, 1, 1 and lower triangular entries be 0, is called row echelon form. Okay? Just as we transformed the lower triangular coefficients to 0, we could also transform the upper triangular coefficients to 0. Why not? Right? Just as we got zeros here by, all these row operations, why not get a 0 here? Why not get 0 and 0 over here? We can try that. Okay? So far what we did was, the matrix we get is called row echelon form. This was Frederick Gauss's approach. Getting zeros even above is by, we'll see, Jordan's method, okay, Gauss-Jordan method. So let's get zeros above. How do I get 0 above? And why do I start from here? Always start from the last one. If you got a 0 here and then try to change anybody here, it would make a mess back over here, okay? So try not doing that. Always start from the last column. I have a 1 here, so let's go back to our row echelon form. I have a 1 here. I need to multiply this by half, add it to row 2. I need to multiply this by negative -2 and add it to this. So let's remember, to get a 0 here, multiply row 3 by half, add. To get a 0 here, multiply row 3 by -2 and add. Okay, so row 3 by half, add, and for row 1, row 3 by -2 and add. So you see you got zeros here. And because this was a 0, nothing else got changed. This was a 0, nothing else got changed. But in this column, that is the outcome column, things got changed. Okay, whatever calculation we did here affected these numbers. So you got a 10 here. Now you see I'm almost done. I need a 0 here. I need to multiply row 2 by 3, add it to row 1. Row 2 multiplied by 3, add to row 1, I get a 0 here. Whatever I do here, I must do here. And I get this. So notice I get identity matrix. You see? Now this matrix simply, immediately, you don't even need backward calculation. X equals this, Y equals this, Z equals this. You got the calculation. So this approach, that is, you get zeros not just below but also above, that is the Gauss-Jordan method, whereas just getting zeros below and then working backward, that is the Gauss method. Okay, this matrix where you get zeros below and above is called reduced row echelon form. Okay, so an M by N matrix A is said to be in reduced row echelon form if it satisfies the following properties. All the zeros, if any, all the 0 rows are pushed to the bottom of the matrix. The first non-zero entry from the left has to be a 1. Okay, reading from the left, the first entry has to be 1, and that 1 is called leading 1. For each non-zero row, the leading 1 appears to the right and below any leading ones in the preceding rows. And if a column contains a leading 1, then all the other entries in that column are 0. So let me explain what they said. Any non-zero row, the first non-zero element you see is 1. If you had more rows, if you had any row with zeros, they get pushed down to the last. You see, these ones are called leading ones and they are in steps. The second row leading one is after. Third row is after. Okay, let's continue in our next video.